Hello friends, in this video we will talk about the transverse nature of electromagnetic waves. Okay, we know that waves can be of two types, either transverse waves or longitudinal waves. Suppose if this is the direction of the wave and the particles of a medium or the varying physical quantity moves perpendicular to this in this manner in which my finger is moving, then the waves are transverse wave. And if the wave propagates like this, the varying physical quantity also moves in the direction of the wave, then the waves are known as longitudinal waves. Right? So we are going to prove in this derivation that electromagnetic waves are transverse in nature. Let us start with this. I have a system of x, y and z axis, and on this system I am having a cuboid. Okay, the name of cuboid A, B, C, D, E, F, G, H. Right, the wave, the electromagnetic wave is traveling in x direction, and in the beginning I will also assume that the waves are longitudinal and the electric field is also traveling in x direction. तो शुरुआत करने से पहले मैं क्या मान रहा हूं, that electromagnetic waves are longitudinal waves. All right, now starting with the derivation, the very first thing to be noted, see, electromagnetic waves, although they have electric component, they have magnetic component, but the charge of electromagnetic waves is zero. ये एक बहुत important property होती है electromagnetic waves की. They have electric component, they have the magnetic component, but they do not carry any charge. Okay, now because they do not carry any other charge, इस पे कोई भी forces आप नहीं लगा सकते, neither the electric force nor the magnetic force. Okay, तो electric force की equation क्या होती है, F is equals to Q into E. What is the charge of electromagnetic waves? It is zero. So what is the electrostatic force on the waves? It is zero. What is the expression for magnetic force? Magnetic force is given as Q into V B sin theta. Again, what is the charge of electromagnetic waves? It is zero. So what is the magnetic force on this? It is zero. तो अगर आप ये सोचते हैं कि electromagnetic waves अगर जा रही है, मैं यहाँ पे कोई भी एक छोटा सा मैग्नेट रख दूँ या कोई भी एक चार्ज रख दूँ, तो वो इसे ऊपर या नीचे या कहीं डिस्प्लेस कर देगा, ऐसा कभी नहीं होता है. ठीक है, एक्सटर्नल मैग्नेटिक फील्ड्स आर नॉट एबल टू डाइवर्ट the electromagnetic waves. What is the reason? That their charge is zero and the electric force as well as the magnetic force on the electromagnetic waves is always equal to zero. Okay, this was one property. Now let us get started. In this cuboid, the electromagnetic waves will enter from this surface and they will come out from this surface. Here again, electric field will be present on this surface, that is ABCD, and on this surface. Okay, the value of electric field has to be different. ठीक है ना? Because what is electromagnetic wave? It is something which changes with space and time. Time के साथ में electric field change होगा. Space के साथ में जब आप थोड़ा distance cover करते हो, then also the electric field is going to change. Right? So suppose this cuboid ABCD EFGH, this cuboid is a Gaussian surface. Right? So I am writing Gauss theorem for this. What is Gauss theorem? Integration of E dot ds equals to Q upon epsilon 0. Now why I have written 0? Because it is Q upon epsilon 0, Q will be equal to 0. Alright, now in this cuboid, how many surfaces are there? There are 6 surfaces. कौन-कौन से? The top, the bottom, the rear, the front, the left side and the right side. Just like we have 6 surfaces inside a room, we have 6 surfaces for this Gaussian surface. I am dividing the surface like this. In the first bracket, I have taken the to and fro surfaces. Which surface? यहाँ पे first bracket के अंदर जो मैंने surfaces लिए हैं, that are this surface and this one. Right, in the second bracket I have taken the top and bottom surfaces, that means this surface and this surface. right? In the third bracket, I have taken the right hand surface and the left hand surface. ठीक है, तो क्या किया मैंने, इसका जो टोटल सरफेस था उसको 1 2 3 4 5 6 6 अलग अलग पार्ट्स में मैंने लिख दिया. All right, but when I sum up all that fluxes, all the flux should be equal to 0. Okay, अब आगे बढ़ते हैं नेक्स्ट स्टेप में. सी द सेकेंड ब्रैकेट एंड द थर्ड ब्रैकेट बोथ आर इक्वल टू 0, क्योंकि सेकेंड ब्रैकेट किसे रिप्रेजेंट कर रहा है, ये वाले सरफेस को, ये नीचे वाला और ये ऊपर वाला. ठीक है, द फ्लक्स, द इलेक्ट्रिक फील्ड लाइज इन विच डायरेक्शन, इट लाइज इन x डायरेक्शन. सो इज देयर एनी इलेक्ट्रिक फील्ड विच इज क्रॉसिंग दिस और दिस? There is no electric flux in y direction, so second bracket 0 हो गया. Again see, electric flux is also in is always in x direction. तो क्या ये इस सरफेस को क्रॉस करके बाहर जाता है या पीछे वाले सरफेस को क्रॉस करके अंदर जाता है? कोई भी इलेक्ट्रिक फील्ड लाइन ऐसा नहीं करती. सो द टोटल फ्लक्स बिटवीन द राइट सरफेस एंड द लेफ्ट सरफेस, दिस टू, they will also be equal to 0. So because the second bracket and the third bracket, both of them become equal to 0, I am left only with the quantities in the first bracket, that is ABCD and EFGH. So integral ABCD, integral EFGH equals to 0. All right, now this E dot ds को मैंने expand कर दिया. कैसे लिखा? E dot ds dot cos 0. Why this is 0? ठीक है, why this is 0? See, here if I take the direction of this surface to be like this, then the direction of this surface should be like this. या तो आप दोनों टाइम पे जब सरफेस एरिया वेक्टर को कंसीडर करो, यानी कि ds को कंसीडर करो, तो either the area should be outside always or they should be inside always. ठीक है ना? You can also choose, आप बोल सकते हो कि भाई सर आपने ये वाला इनसाइड डायरेक्शन चूज किया है, मैं इसको आउटसाइड चूज करना चाहता हूं, तो you can do that. You can choose this direction to be outside, then this direction of this area vector EFGH also has to be outside. I am choosing it to be inside. Okay, so what is direction of electric field? X-axis. What is direction of this area vector? X-axis. What is the angle between them? It is 0. Here the direction of electric field is x-axis, direction of surface area vector negative axis. So what is the angle between them? It is 180, right? Suppose the electric field on this surface is EX1 and the electric field on this surface is EX2. Clear? This surface area ABCD and this surface area EFGH, दोनों का magnitude same होगा. So this surface area is also equals to S. This is also equals to S. And now, why there is a negative sign in the second term? It is because of this cos 180. Cos 180 is equals to minus. What is EX1? Electric field over here. What is EX2? This is electric field over here. Okay. So now expanding this becomes negative. S यहाँ पे cancel out हो जाएंगे and you shift this EX2 on this side. What do you get is EX1 is equals to EX2. यानी कि this sentence, this conclusion means that electric field at this point and the electric field at this point, they are equal. This is simply not possible because in electromagnetic waves the electric field cannot be static, it cannot be constant. मतलब आप यहां से यहां गए, इलेक्ट्रिक फील्ड चेंज ही नहीं हुआ, मतलब इलेक्ट्रिक फील्ड कैसा हो गया? कांस्टेंट हो गया. और कांस्टेंट इलेक्ट्रिक फील्ड कभी भी आगे मूव नहीं कर सकती, प्रोपोगेट नहीं कर सकती. इसका मतलब क्या हुआ? इसका मतलब EX1 is equals to EX2. ये गलत स्टेटमेंट है. This is simply wrong. जो कंक्लूजन है वो रॉन्ग है. कंक्लूजन रॉन्ग क्यों हुआ है? बिकॉज इन द बिगिनिंग वी हैव assumed that इलेक्ट्रोमैग्नेटिक वेव्स आर लॉन्गिट्यूडनल, उससे ये वाला एक्सप्रेशन आया. इसका मतलब अपन ना जो एजम्पशन था दैट वाज आल्सो रॉन्ग. That means electromagnetic waves are not longitudinal. Now if they are not longitudinal waves, what kind of waves they are? They are transverse wave. तो in this proof हमने सीधा सीधा कान नहीं पकड़ा, हमने घुमा के कान को पकड़ा है, ठीक है. We wanted to prove that electromagnetic waves are transverse in nature, and what we have proved? We have proved that electromagnetic waves are not longitudinal. Now if they are not longitudinal, they have to be transverse.